We will have Chris Horn presenting KFILND and UDSP.
Chris Horn is a software engineer on the Lustre team at HPE. He has been involved in with Lustre since 2009 and is currently a maintainer of the Lustre network code.
Hello, thank you for the intro. This talk is largely about UDSP, but I'm going to give a quick overview of the KFabric Lustre network driver and spend the bulk of the talk talking about the LNet user-defined selection policy feature. And then at the end, talk about how we leverage UDSP to address a serviceability issue that we have with KFILND. So KFILND is as I said, is the KFabric Lustre network driver. This is the LNet driver that we use for kind of the best performance on the Slingshot 11, I'm not up on my HPE marketing lingo, the HPC Slingshot interconnect. Uses numeric-based LNet NIDs as opposed to IPv4 like you have with SOC LND and O2IB LND. The network name is KFI. And that NID number is this thing called the destination fabric address, which is part of the HPC protocol that runs on Slingshot. And that DFA reflects sort of the physical connections of the network. So that it reflects the group, switch, and port numbers. And I just mentioned that because that ties into this resiliency issue that I'll talk about at the end of this presentation. So it implements the LND API using this thing called KFabric. And if you're interested in looking at the code, we've submitted it to the community, and it's more or less up to date. We regularly push bug fixes or performance improvements, that sort of thing. And so you can check that out in master, and it'll be released with Lustre 2.16. So what is KFabric? Many of you will be familiar with libfabric, which is used for applications to provide RDMA services. And KFabric is really just the kernel analog of libfabric. So it provides a network agnostic API for RDMA in the kernel. And that API is really designed for storage use cases. It was envisioned as a common mid-layer that could be used by multiple upper layer protocols. So it's kind of similar to LNet itself. LNet abstracts away the underlying network types from Lustre, so Lustre doesn't have to know if it's running on InfiniBand or Ethernet networks. And then like Lustre, or like LNet has the Lustre network drivers to interface with the underlying network type or the underlying network drivers. KFabric has these things called providers that interface with the drivers. So interest in KFabric kind of died out. HPE is currently the only one really using it. So KFI CXI is the only provider, and that's for our HPE Slingshot network. So a little bit about Cassini, the Slingshot interconnect. It's at the hardware level, the Cassini link is an Ethernet link. But it also natively supports Ethernet L2 layer, so it can natively do Ethernet traffic, and we have a good Ethernet driver implementation. And sort of alongside that L2 layer, the Ethernet L2 layer is a Portals 4 RDMA-based RDMA implementation within the NIC. So there are features to accelerate a Portals 4-like API in the hardware, and this is what our RDMA software stack is built upon. It's PCI Gen 4, 200 gig, supports virtualization with SR-IOV, and if you were curious, CXI stands for Cray Exascale Interface. This is just a little picture showing the software stack. What's kind of interesting about this is, because we support Ethernet, we not only can run our KFILND using the HPC protocol for that native performance, but we can run SOC-LND as well. And we're also developing a software Rocky driver, or doing a lot of work on the software Rocky driver. So with Cassini, you can run all three of the LNDs available in LNet, KFI, O2IB, and SOC-LND. Okay, so now we'll talk about UDSP for a while. So the user-defined selection policy is a new LNet feature in Lustre 2.15. Shout out to some of the developers and testers that did a lot of work on this feature. The motivation for this is that with LNet multi-rail, sort of by definition, you now have multiple paths between LNet peers, and some of those paths may be better than others. UDSP allows system administrators to define optimal paths between peers so that you can achieve performance or resiliency goals. It's controlled using the LNet Cuddle CLI, and there's support for YAML configuration, just like other LNet configuration. And there are 4 or 5 different rule types that influence the LNet path selection, right? So you can kind of use these rules in different ways to influence the path selection to get those optimal paths through the network. And we'll talk about each of these in turn, starting with the local net and NID selection priority. This is really 2 rules, but they're so closely related, we'll consider them together. So to kind of understand UDSP, it's useful to understand how LNet path selection works in a multi-rail environment. So in this example, I have a client sending a message to a server. Both the client and the server have 3 network interfaces. 2 of them are Cassinis on KFI, and you've got another one that's on a TCP Lustre network. So the first thing that LNet does is it will select a local network for the send. And in this example, we'll just say it picked KFI. Second step is it selects a source interface on that local network for the send. And then lastly, it selects the destination interface on that network for the send. And at each step, LNet considers various criteria, such as LNet health was added in 2.12, so that's kind of the top priority, or it should on the bottom right. So we select the interface on the server that we want to send to, and then we look up in our very simple route table at the bottom there, a suitable router NID. And then once we've done that, we select one of our local interfaces that we can use to send to the router. And again, we round robin when all else is equal, right? So in this particular example, you have the servers on a network where each server is connected to a top-of-rack switch. And we have these dotted lines, which are inter-switch links between the top-of-racks. And so in this case, we've taken the shortest path through here. But if we are sending another message to the server and we get to step 3 and we round robin, now we select the top router, and now we've got to traverse these inter-switch links through the network to reach our destination. So this introduces latency, and it's actually what LNet fine-grained routing was sort of invented to solve. So in fine-grained routing, we define optimal paths through the network by kind of splitting up the servers into multiple groups, separate LNets, and then we define the optimal paths via the route table, right? So in this case, when the client is sending a message to server 3, there's only one available route, which is the optimal path through the network. This does, this is a very simple example, right? In a real production system, you'd have multiple routers in each of these groups, for performance and redundancy. But it does reduce the total number of available paths. In this simple example, I can no longer use 2 of the routers to reach server 3 here. So UDSP can define the optimal paths here as well using the pure router rules. So this works kind of similar to the source NID selection, where you define a list of preferred routers for each server interface in this example. So, I tell my clients, if you're sending to server 3, you should prefer using this router here, 3 at KFI. And so this gives us the optimal paths that we want, but the other benefit is, all of the routers are still available to the clients. We haven't restricted them. We have the simple route table, right? They can use any of the routers. So if this 3 at KFI fails, then the clients can just seamlessly, fail over to the other LNet routers. And it's, arguably a simpler way to place a configuration compared to something like FGR, which can get very complicated. Okay, so I mentioned UDSP supports YAML configuration. I just wanted to highlight a few issues that I discovered when testing this feature. So a common way to generate an LNet YAML config is use the CLI to place the configuration and then use this export command to generate a file that you can just save. But the output that this generates for UDSP cannot later be imported. So the problem here is shown on the right, which is when you run export -- backup, UDSP, or the output shows these NA strings for these unused fields for this particular rule type. And when you go to import this, LNet kind of doesn't understand it. So that's just something to be aware of. You can do this, but just delete the NA lines, and I'm showing there on the left what a good configuration looks like for this source net selection priority rule. The second thing is that UDSP rules cannot be combined in the obvious way. So again, on the top right here, I have sort of the bad example. So I've got a source net selection rule and a pure net selection rule. This looks like it ought to work, right? You've got different indexes, you've got 2 rule types, but you go to import it, and the import, when it's looking at that first rule, it kind of scans ahead and says, oh, there's a destination field, and so it adds that into the first rule, and now you've got sort of nonsense. So there's a simple workaround for this, which I show on the left there, which is you just separate each of your rules with this UDSP block, and LNet will interpret it correctly.
It's just so different from the other LNet setups with using the UDSP.
Yeah.
Yeah.
Well, so
That's very different.
we can talk about this during Q&A. Okay, so back to KFILND and sort of this administrative challenge. So as I mentioned, the NID number is this DFA thing, which reflects the group switch and port numbers. So if you swap your cables, you've got a different DFA. And new DFA means new LNet NID, and Lustre really doesn't like when your NIDs just go changing on the fly. So on a Lustre server, if you change your NIDs, you need to do like a write conf or lcuttle replace NIDs. If your MGS NID changes, you have to update client's FS tab, maybe. If you have routers that get a new NID, it invalidates your routing tables. You need to go update that. So this is an administrative headache. So I had this idea that, you know, because HPE Slingshot supports SOC LND in addition to KFI, you know, is there a way that we can get the benefit of IPv4 addressing and still get the performance out of native KFI? So I had this idea to just, you know, we can configure both LNDs on our Slingshot interfaces and then use UDSP to favor traffic to KFI, right? So the idea here is if you were doing this on a Lustre server, you format your file system using only the TCP NIDs on your router, in your route tables, just, you know, anywhere you encode NID information, you just do the TCP NIDs. That way you don't have these DFAs anywhere. And then when you go to mount the file system or whatever, LNet multi-rail just kind of works its magic. And so you've got the initial discovery traffic will go over TCP because that's all Lustre knows about. And discovery finds the KFI NIDs. UDSP rule takes effect, and now all of your future traffic, file system traffic, goes over KFI, and so you get that performance from the HPC protocol. And so the YAML config here just shows how you would emplace this.
Does that work?
Does it work? Yeah, it works. And in fact, we do this for DBS servers on Cray EX systems. Okay, so the eagle-eyed among you may have noticed that in my examples running LNet self-test, I was running this lst.sh script, which is the new LNet self-test wrapper that I contributed to the community along with this LST survey. So I just wanted to highlight that. It's part of the Lustre IO toolkit. So another tool available for you to check LNet performance and validate your networks are working correctly. The PeerNet, right, so there was one part of the path selection that you couldn't influence with UDSP, which is the first step in router configuration where you're selecting that destination network. And the code was there, but it was buggy. And so there were a couple tickets there. I think these have all landed now for 2.16. So with those fixes in, you can now influence every path selection in any configuration. There was a small memory leak that's also fixed. The YAML issues, the ticket for that is shown, but that has not been resolved yet. And that's all.
If we have short questions for Chris.
Friendly fire here.
So it seems. So it seems like that this is pretty powerful, but also fairly complicated to understand. Is there? I was just imagining as you were talking. Is there a tool that we could have give me that could just check all the speeds on all the various links and just set up the right UDSP rules for you?
Such a tool does not exist, but yeah, I mean, we talked about this a little bit during the developer workshop, and I think there are things we could do, whether, building some smarts into the Lustre network drivers themselves, right? So that they can, rather than having sort of a top-down where LNet defines the behavior, you could maybe have it bubble up, right? Where LNDs could sort of advertise like, hey, I'm a 200 gig NIC, so use me accordingly. And LNet could just sort of, do this sort of configuration on its own without any user intervention. I think that would be useful.
Just a question for you. About the new UDSP feature to configure a kind of route, okay, when you add the routers parameters, does it mean that we don't need anymore the old configuration to configure the routers or not?
Well, so you still need the route table.
Okay.
Yep, you still need to define your routes.
Okay.
Clients need to know where the next hop is, right?
Okay.
So yeah, you still need that piece.
Okay. Okay.
No other questions? Okay, thank you, Chris.
Yeah, thank you.